Hello student, welcome to my online classes. In this video we are going to do workout examples on function, their inverse and composition. In this video we are doing those questions where composite inverse with their composite function of the inverse and composite, the both uh, both topic are mixed in these workout examples. We have already done a composite function example on composite function, as well as we have already done examples on inverse function. So we know how to find composite of two function, and we know how to find inverse. So when they are combined, when we are doing those examples, let's see the example one. Our example one is, you can see the question on your screen. All the questions, there are 14 or 15 examples here, and each and every example are very important, because they are the selected 15. Actually you can say they are the selected 15 and they are very important question. And the question right here, there's now two functions are there, f and g, and which are defined. Fx is defined as 2x minus 7 and gx is given as x plus 2 by 3, and the composite of function f and g is equal to g inverse x. Whenever a student you see inverse, then first thing you have to do is just find the inverse. Okay, then and then you can do composite, or just see the given part of the question. Here this is the given part of the question, and you can find inverse first, or you can do composite first, and then you can uh, apply the given condition. You can easily find the value of x. Now the solution is here, the two given functions, and condition is given. Now you can see there is a condition, there is a two function and condition, and first thing we are going to do is we are going to find the composite. You can find the inverse also. First we are going to do composite of f and g. Now you know how to find the composite function, isn't it? Now g is the function which takes the input first, because it is closer or nearer to the input variable x. Our input variable is x, and our function g, it takes the input first. Now what is the value of gx? So you can see in our question the value of gx is x plus 2 by 3. So we will just put, instead of gx, x plus 2 by 3. Now what we are going to do, now the input for the function f is x plus 2 by 3. Input for function f, see, this is the function f and this is the input for function f is x plus 2 by 3, and input value takes the position of input variable. See the input variable is x. Now we have to replace this x by x plus 2 by 3. That's how we find the composition, isn't it? Because the output of the function gx is the input for the function f. That's what is composite, isn't it? This is the value of gx, and you can say this is the output of function, because it's fx is always equal to y, isn't it? Fx is always equal to y. That means 2x minus 7 is output. In this case also gx is equal to y, and you can say this is the output, x plus 2 by 3 is the output, and x is our input. So output of the first function g is the input for the second function f. So our input will be x plus 2 by 3, and input will always take the position of input variable, that is x. So the x of function f will be replaced by x plus 2 by 3. Now you can see the same thing is written. Now replace all x, wherever there is, it's only one x we have to replace right now. Replace all x of function f by x plus 2 by 3. Now as we replace it, 2, see, this x is replaced by x plus 2 by 3, isn't it? Exactly, it's replaced by x plus 2 by 3 minus 7. On calculation you can see 2x plus 4 by 3 minus 7. We have to take LCM because it's a fraction. It's 7 by 1 here, right here. So our LCM will be 3, and this 3 will goes and multiplies with 3, multiplies with 7. That's what LCM is, 2x plus 4 minus 21. And on further calculation we found what we found? We found composition of f and g to be 2x minus 17 by 3. Now we have done one part of our question. Another part, that's the inverse, and I think you know very well how to find the inverse. And if you have forgotten the steps, then you can see on the top right corner. Those are the steps. First step is we have to suppose y is equal to x plus 2 by 3. We have to suppose the given function to be y is equal to uh, so we have to find the function inverse of function g. So we have to suppose y is equal to gx, isn't it? This is the value of gx. In this step it's written fx, so don't get confused. Okay, here we have to find the inverse of gx, so we have to suppose y is equal to value of gx, that is x plus 2 by 3. Now the second step is interchanging x and y, and we interchanged x and y. X is replaced by y and y is replaced by x, so cross multiplication. After cross multiplication we get 3x. That cross multiplication means this 3 will go to the left side and multiply with x, that is y. 3x is equal to y plus 2. Now y, we have to make y, still y is not alone, so we have to bring this 2 of right hand side to subtract with 3x of left hand side, so 3x minus 2 is equal to y. Now our y is alone, and according to the step, in third step, you can see the alone y is the inverse of the given function, so our inverse is g inverse x is equal to 3x minus 2. That's our inverse. Now it's pretty easy. We have to apply the given condition, which is given in our question. This is the given condition, and we have to apply because we have f o g x also and we have g inverse x also, so we have both things. According to question, we have both part of the given condition, left part and right part. Our left part is f o g x and right part is g inverse x, right hand side is, so we have to apply g o f x. So don't get confused from where this came. It came here, right here we have already done, and g inverse also we have done. So now cross multiplication, in this the denominator is 1, so when 1 multiplies with 2x minus 7, it is 2x minus 17. Then when 3 multiplies with 3x minus 2, 3 bracket 3x minus 2, after multiplication you can see 2x minus 17 is equal to 9x minus 6. We have to bring the 9x to the left hand side because like term must be kept on the same side, and other like term will be kept on another side. So number on the right hand side, terms with variable on the left hand side, that is minus 7x is equal to 11, and answer is x is equal to 11 by minus 7. Now that's our answer. This question is very easy, just to do what is apply the given condition of the question and do what is necessary, isn't it? Yeah. To find the composition of g was necessary, we did it. To find the g inverse x was necessary, that also we did, and we just applied the condition. So you can pause the video and you can note it down. We will quickly move to next example. Try this. Okay, it's not example, there are a few questions which you can see the question. It's exactly same question, same type of question. If you have understood the previous example, then you can easily do this question, these questions, same question. See the condition here, right here it's the condition, there is the condition. Here you have to find f of fx, which is also easy, f of fx and g inverse x, and another f of fx and g inverse x. Similar type of question. 4, 5, 6 are this example. So let's move to another example. Example 2. Same sort of question. It's a given condition. This is the given condition, and what we have to do is we have to find f inverse first, and we have to do the composition of g and f inverse. First thing we need is f inverse. So if it is clear, then it's a given value here, and it's a given value, and we have to find f inverse. First thing we have to do is we have to find the f inverse, then we have to do composition, because first we can do composition. Here we can do composition because we don't have f inverse, we only have f. We need f inverse, so we have to find the f inverse, and the steps, if you have forgotten, then it's on the top right corner. First we have to suppose let y is equal to 2x minus 7, and I'm going quickly on this because it's I think you have done lots of question on you have found inverse of lots of question, lots of functions. So it will be easy. We have interchanged the value of x and y, then x minus 7 is equal to 2y, x minus 7 by 2 is equal to y, or the alone y is the inverse is equal to y. So if y is alone after interchanging, if we make y alone after interchanging, and then that y is the inverse of the function. So f inverse x is x minus 7 by 2. So we did this part, and then we now have to do the composition of GOF inverse x. So that will be, now f inverse is the function which takes the input first. So f inverse x, just now we have found f inverse x, x minus 7 by 2. Apply it. Now this is the output of f inverse x. X minus 7 by 2 is the output of f inverse x. Input is x, so output is x minus 7 by 2. Now output of first function, that is f inverse x, is the input for the second function g. So all x of g must be replaced. All x, this time we have 2x right here, right here. So these 2x will be replaced by x minus 7. So same thing is written. Now replace all. Now replace all x of function g by x minus 7 by 2. There are 2x, so we have to replace it. You can just see it. Say the x is, the circled x is replaced by x minus 7 by 2 because it is the input of the function g. So input takes the position of input variable. Input variable is x. So input value takes the position of input variable. Now remember the formula. We need this formula right here. X minus 7, a is x and b is 7. So we'll open the bracket with this formula. We'll expand it. X square minus 2ab. It is ab, x is a, and 7 is b, and b square by 4. 2 square is 4. You can cancel this 2 and this 2. After cancellation, x minus 7 only. So 14x, 7 to the 14x plus 49 and 4 after taking LCM. After taking LCM, this 4 goes to this side, isn't it? Because LCM of these two fractions is 4, because this fraction, the value of this fraction, denominator of this fraction is 1. So LCM is 4. After taking LCM, now we have to multiply it. X square minus 14x plus 49. This is the first part, and 4x plus 28. The sign changes because of the minus sign. Minus into minus plus. This sign is plus. We have to be careful because the student tends to make a mistake while changing sign. X square minus 14x, 18x, because we have to add this 14 and 4 in same sign, addition. So 49 plus 28, 77. So we quickly move to another step. That is according to equation. We have to apply this given condition. Now we have the composition GOF inverse x right here. GOF inverse x is this value. This is GOF inverse x, isn't it? GOF inverse x. It's GOF inverse x. This is GOF inverse x, and GOF inverse x is according to equation is equal to 3. That GOF inverse x is 3. Now we put the value GOF inverse x, x square minus 18x plus 77 by 4 equal to 3. Cross multiplication, x square minus 18x plus 77 is equal to 3 into 4, that is 12. This 4 multiplied with 3, that's 12 x square. Now we have to bring this 12 to left hand side so that we can factorize it. Or x square minus 18x plus 65 equal to 0. Now we have to find the two numbers. Which product is 65? We have to find the two number which product is 65 and which sum is 18. The two number which sum is 18. We don't take the sign that 18. We don't. It has a minus sign. We don't care about it. We have to find the value. The two numbers are 13 and 5, isn't it? 13 5 ja 65. 13 plus 5 18. 13 into 5 65. 13 plus 5 18. So two number is 13 and 5. X square minus 13 plus 5x plus 65. We have to open the bracket and we have to be careful about the sign. X square minus minus 13 and minus 5x. So a student usually make mistake right here. So while changing the sign, so we have to take common on. We have to take two terms. and two terms, first two term and last two term. So in first two term only x is common, x minus 13. In last two term minus 5 is common, so x minus 13. Now, or x minus 13 is common from two terms, x minus 5 is equal to 0, and either x minus 13 equal to 0, x is equal to 13, and we have to do the OR part. In OR part, x minus 5 equal to 0, either that term is, that factor is 0, or this factor is 0. Now x is equal to 5. Our answer are x is equal to 5 and 13 are the answer. Find the values of x. It must be find the values of x. It has two values. So hope you understand it. This first example and second example are not so very much different between those two examples, and they are relatively same type of example. So let's move to another. I think you have an exercise. We have exercise. So you can do this question. You can try this question. Same type of question. Here we have to find G inverse first, and then do the composition of F or G inverse X. So there are two answers. Find the values of X. So 1 and 9. Now let's do the third example. Example 3 is right here on your screen. We have to find G inverse also. We have to find F inverse also. Then we have to do composition of F inverse and G inverse. Then our input will be 1. Then we have to find the value of we have to find the value of entire G inverse X, not X. It's question, I think it's a mistake. Now we have to find the value of this composition function value of this composition of our function. Here fx is given as 3. Now fx is 3, fx is given, so we have to bring this 3 to the denominator of right side for x plus 5. So you don't have to be confused. The students shouldn't be confused in this part. And now our priorities are, priority means what we are going to do step by step. First we are going to find F inverse, then we are going to find G inverse, then we are going to do composition, then we are going to input x is equal to 1 at last. So to find F inverse X, quickly you can find the F inverse because you can see these steps. Let's move quickly because inverse part you can easily do it. Interchanging, after interchanging you can see y is replaced by x and x is replaced by y, x is replaced by y and y is replaced by x. Interchanging, now we have to make y our y alone. 3x is equal to 4y plus 5, still y is not alone. 3x minus 5 is equal to 4y, still y is not alone. Making y alone means it must y must have coefficient 1. If y has the coefficient positive 1, then that is y, that's called y is alone, and that's where we call y is alone. And now 3x minus 5 by 4. Now right here the coefficient of y is positive 1, so it's alone. Now then that alone part represent the inverse, F inverse. Easily we found the F inverse. So similarly we have to find G inverse also, and G inverse is y is equal, G is gx is 5x minus 4, so y is equal to 5x minus 4. Interchanging, same steps will be repeated. Or x is equal to 5x minus 4, then we have to make our y alone, so x plus 4 equal to 5y. Y is still not alone because its coefficient is 5, it must be positive 1. If the coefficient of y is positive 1, then we can say it is alone. And now to make it positive 1, we have to do x plus 4 by 5. We have to bring that 5 to denominator of left hand side, so it's alone. This alone part is the G inverse. Now we found F inverse, we found G inverse, and now we have to do composition of F inverse and G inverse. And now, if you haven't understood composition also, you can understand right here. F inverse, G inverse X. So what is the value input of G inverse is X, so its output is, you can see the output, x plus 4 by 5 is the output of G inverse. So the output of first function will be the input for second function, that is F inverse. First function is G inverse, second function is F inverse. So output of first function is the input of second function, second function is F inverse. So input takes the input position of input variable. Our input variable is 3. Right here you can see that's 3. So Now replace all x of f inverse function f inverse, all x of function f inverse by x plus 4 by 5. So let's move forward. Let's replace it. So see here that this x will be replaced by x plus 4 by 5 minus 5. Now we have to multiply the denominator of this fraction, numerator of this fraction by 3, not denominator, only numerator. 3x plus 12 by 5 minus 25, minus 25 because we have taken LCM also on the upper part. Now this 5 and 4 will be multiplied. It won't, the 4 won't go to the numerator of this part, okay? You don't get confused. It won't go to right here. It's if you do this, then it is a mistake. Just multiply 5 and 3x minus 13 upon 20. Now this is our f in composition of f inverse and g inverse when x is equal to 1, because our input is 1 for this function. Input is 1 for this both composition is a single function, isn't it? This two composition of these two function is also a single function. For that single function the input is 1. Now we have to replace x of that function with 1. See this, now this is the input, so input takes the position of input variable. It's so simple. Input takes the position of input variable. Now on calculation, you have a calculator, you can do calculation. It must be minus 1 by 2 right here. If you need this step, then it's 3 minus 13 upon 3 minus 13 upon 20, which is equal to minus 10 by 20. 0 0 cancelled, isn't it? We can cancel 0 and 0. That means our answer is minus 1 by 2. So pause the video and note it down. Let's move. Now the exercise, it is there are I think more than one question because it's written try this. Now this is the question. You can try in the same way. This is also another question you can try, and there are the answers also. Move to another. You can pause the video. Okay, I'm moving quickly, so you can pause the video and you can note it down. Now this question, in this question we don't have to find f inverse and g inverse. See, it's the inverse is outside of the bracket. You have to be careful about this. If the inverse is outside of the bracket, then first we have to do the composition of g and f. First we have to find the composition, and then we have to find the inverse of that composition. Now this, it's different than the example 3, example 4. Let's see our given, it's a given part, and our priority is to find, see, we don't have gx, so first priority is to find gx. We have to find gx, then we have to do the composition of g and f. We don't have gx, we have this part, and we'll apply this part and we find gx. So g and takes the inverse, g takes the input first, so it will be easy to find gx. We suppose gx as x. Now let's see, to find gx, let us suppose gx to be a. We suppose gx to be a. Then let's see from our given part. Now in this composition, g is the function which takes the input first, means gx does not gx is defined, is supposed as a, so we have to put the gx is equal to a, f a equal to 4x plus 3. Now the output, it's the output of a, is the output of function g, isn't it? X is input, and a is output. So output of first function is the input of second function. Our second function is f, so input of second function is a. What it means is, now x will be replaced by a. X will be replaced by a. Now you can see the same thing, and now x of function f will be replaced by a. It's very easy. Or 2. Now we don't have to replace by this. Okay, this part is a totally different thing, and here this will be exactly same, and only this part we have to see. Here what we have to do is we have to replace the input variable x by a. Just see 2a minus 7, which is our input function was 2x minus 7. X is replaced by 7. Now we have to find the value of a. We have to make the a alone, or 2a minus 2a is equal to 7 goes to another side. We have to make alone. So a is equal to, what is the value of a? 4x plus 10. Now you can take 2 common from the right hand side, and we can cancel 2 and 2. that means a is equal to 2x plus 5, or a is equal to 2x plus 5. That 2x plus 5 is our gx, because we have supposed a to be gx to be a, isn't it? Now we have to find the composition g or f. Now f is the function which takes the input first. So for function f, x is input and its output is 2x minus 7. X is input and this entire this part, this formula part is output. So g 2x minus 7. So that's the output of function f, and it is the input of function g. In composition, output of first function is the input of output of first function is the input of second function. So this is the input. So it will be replaced. It will replace the x of function g. Function g is right here. That this x of function g will be replaced by 2x minus 7. So what it will be? Let's see, 2 bracket 2x minus 7 plus 5 on multiplication 4x minus 14 plus 5, that will be 4x minus 9. Now we have our composition also. Now we have to find the inverse of this part. Okay, we have to suppose y equal to 2x minus 6. Now to find g or f inverse x, let now steps is in the bottom of right side. Now we have to suppose y is equal to 4x minus why you have to raise the question, you have to ask the question, because why 4x minus 5, because we have to find, it is in the bracket, means the entire composition. We have to find the inverse of entire composition g or f. So let interchange it, and you can see after interchanging, now y must be alone. It's still not alone. Making alone means coefficient of y must be positive 1. Now that's the inverse x plus 4 by 9. Okay, it's also important question. All questions are important because only selected questions are picked and they are done as workout example. So we can. Now I think this is exercise. There is one question. You can if you have understood the previous example, then you can do this question easily. Okay, let's see another example. Example 5, which is on your screen. Now the question, there are two functions and there is one given condition. There is one given condition. The given condition is you can see the given condition. This is the given condition. Now we apply this given condition and we to find the value of b. First we have to find the value of b, and now you can see the solution. You can see the given part of the question, and to find g o h x, first we have to find g o h x and composition of g and h. Now h is the function which takes the input first, so x is the input and output is x 2 minus x is the output. So if x is the input, then output will be this. So we have to write the output of function h, that is x 2 minus x h. Hx is replaced by this. Now output of the first function h will be the input for the second function g. So input is x upon 2 minus x. So this part will replace the x of function g. Wherever there is x on the function g will be replaced by the input x upon 2 minus x. Now x of function g will be replaced by x2. You can see on the screen b x 2 minus x minus 2, which is equal to bx on, we have to take the LCM also, so minus 2 bracket 2 minus x. The LCM, this part will goes this side and multiplies with 2. On multiplication you can see bx minus 4 plus 2x upon 2 minus x, and we can't do any more simplification, so we'll just leave it. Now to find, we input on this composite function, we put input 4, we take input as 4 for entire composition and not for a single h function. We can do as one by one also. We can just take for the h function and then we can apply on the g function also. You can do that also. We have g o h x is equal to this is our composition of g and h, and now our input will be 4, so we have to replace x by 4. G o h x 4 equal to b dot 4 minus 4 plus, and on calculation you can see that's minus 2, and on minus 2. According to equation, you can see, according to equation, GOH4 is equal to 8. It's a given condition. We're applying the given condition. We will use the value of this, which we have found here. We have calculated there, and on cross multiplication, 4b plus 4 is equal will be 16 minus minus plus 4b plus 4 is equal to 16. Now 4 will goes to right hand side, 4b, or 4b equal to 16 minus 4, that will be 12. 4b is equal to 12. You can cancel 4 and 12, and it goes by 3. So value of b will be 3. Now we put the value of b on our gx. So now gx is equal to 3x. 3x, b is replaced by 3, isn't it? Now b is replaced by 3, putting the value of b on function gx. So now we have to find the inverse of gx. To find g inverse x, you can see this step on your top right corner of your screen. Now the steps are very simple. You are very much familiar with it, habitual with it, and you can do it easily, isn't it? Interchanging, and now making y alone, that is x plus 2 by 3, isn't it? Now we found the g inverse. Now when x is equal to 1, our input must be 1 because it's 1. It's given, it's asked on the question. We have to use the input as 1, and input replace the input variable. So x is replaced by 1. 3 by 3 is equal to 1. So our answer, that's the question for you. Try this. Now this question looks difficult. You can see in the given condition, it's not difficult. Okay, you just set the priority. First find g inverse x. Our first priority is to find g inverse x, then find g inverse 6, find g inverse 6 also. Do step by step, one at a time. Then find composition of f of g also. F O G x. This is the third part of the question. First find g inverse x, second find g inverse 6, then find f O G x, then multiply these two and equate with 1. Then that will lead you to the correct answer. So another question, you can see f O f2 is equal to here also. Just find the composition of f O f, then apply the input 2, then equate with 10. And after you found the value of k, put the value of k here, right? Like it is just similar to the previous example, and you can do it. There is another question also. These are similar type of question. Our next example, I can see on your screen. This is our question function. This is easier question, isn't it? We just have to find the g inverse and we have to equate with the fx. And so our priority will be to find g inverse. So you can see the given part here. This is the given function, and another given function is this. To find g inverse x, we have to find g inverse x first. Now you can see this step on your right side of your screen, and let y is equal to x minus 3 by 2, then interchanging x and y. You can change in x and y, then after interchanging we have to make y alone. Still y is not alone, so y is alone, then it is inverse. 2x plus 3 is our inverse. Now according to equation, we can quickly move to according to the equation. What is according to equation? Fx is equal to g inverse x. Now we have to put the value of x, substitute the value of fx, 3x plus 11, x minus 3, and g inverse x is 2x plus 3. And on cross multiplication, you can see the cross multiplication on your screen. 3x plus 11 is equal to x minus 3 bracket 2x plus 3. They are grouped in a bracket. Now we have to multiply it, this part. Just remember what you learned in junior classes, lower classes. 3x plus 11 is equal to x. Now this 2x plus 3 is repeated, and I have repeated, and I have divided this part, isn't it? X minus 3 is divided, and 2x plus 3 is repeated. So you can see the repeated part. Now on multiplication, 3x plus 11 is equal to 2x square plus 3x minus 6x minus 9. We have to be careful. This minus sign, change the sign. This minus into plus is always minus, into plus is always minus, so it's minus. And now we have to bring everything of left hand side to right hand side. Now 2x square minus 6x minus 9, and we just cancel this 3x and this 3x, So only 11 will come to right hand side. 2x square minus 6 minus 9. Now it is 0 is equal to 2x square minus 6x minus 20. And now we can take 0 2 common. It will be easier for us. 2x square minus 3x. After taking 2 common, 3x minus 10. Now as 2 is not equal to 0, isn't it? 2 is 2 0? No, so second part must be 0. So x square minus 3x minus 10 is 0. Now we have to factorize this, or x square minus 3x minus 10. Now you see here, right here, now we have to find two number. The two number are 5 and this 3 can be divided as 5 and 2. If we multiply 5 and 2, our product will be 10, and if we subtract 5 and 2, it will be 3. We studied this first. You studied this first on class 8, isn't it? Factorization of trinomials. Now you can see on factorization, x square minus 5x plus 2x. You have to, student usually make mistake in this system. You have to be careful. It minus into minus, it will be plus. On taking common, x bracket x minus 5 plus 2 common. In these two terms, we have to take two terms at once. From these two terms, x is common. Only x is common, so x minus 5. 2 is common because 10 is 2 into 5, isn't it? 10 is usually 2 into 5, is always 2 into 5, and so 2 is common. You can clearly see 2 is common, so taking 2 common, x minus 5. And now still our 4 terms reduces to 2 terms. Right here you can see only 2 terms, so x minus 5 is common. After taking x minus 5, the remaining x plus 5 is grouped of one bracket. So either x plus 2 is equal to 0, or x minus 5 is equal to 0. X minus 5 equal to 0. So x is equal to minus 2 and x is equal to 5. So our answers are x is equal to, I think it's exercise for you. Now try this, only one question. F is equal to f in. Now example 7. Now here you can see there are two functions, and what is this? F square f. It is f square f is f composite f. Okay, you don't have to be confused. F square is f composite f. F composite f is written as f square is equal to 4 by 5. So no need to be confused about this. So let's start. Solution. Here, that's the given part of the question. Everything is given. F, G, and composition of f and f is given. And first we start with f square f. F square 5. So let's do it f or f5. Now you can see, now input for the function f is 5, isn't it? Input is 5, so input takes the position of input variable. So x of function f will be replaced by, now see, now x of function f will be replaced by 5. It's very easy. So let's replace it. F bracket k 5 3 minus 5, isn't it? X must be replaced by 5 because our input is 5. So this output k by minus 2 is the input for the function. Now x of function f will be replaced by k by minus 2. Now we are going to replace the x of function f. Now this time another f equal to same function. Previous function has given output x k by minus 2. So k by minus 2 will replace the input variable x of function f. So this x will now be replaced by k by minus 2, or k 3 by minus 2, or k upon 3 plus k by 2. Now minus into minus plus, so we have to take LCM of this denominator part only, or k upon 6 of 6, 3 to the 6, it will be 3 into 2 plus k. Now or k upon 6 plus k by 2 is equal to 4 by 5, or on cross multiplication. Okay, this is a cross multiplication part. We multiply this and this, isn't it? 4 bracket 6 plus k. Now 10 plus 24 plus 4k after multiplication and opening the bracket. And now like term 10k minus 4k is equal to 6. Like term must be on one side. So 6k is equal to 24. Our value of k is 4. Now you can see on your screen 6 for the 24. So 6 1 is 6, 6 for the 24. So we have to replace the value of k. Now our function f will be, now fx will be 4 upon 3 minus x, because the value of k, we have found value of k to be 4, so we can replace it. Now another, we have to find the function g. So to find the function g, we will use this condition. Now let's see. Again, we have now g is the function which takes the input first. So f big bracket g2. Now x of the function g will be replaced by 2. Isn't it? Input is 2. That's why x of g will be replaced by 2. Now, or f 11 minus p square equal to 1 by 2. Now you can clearly see x of the function g. This x is replaced by 2. Input value takes the position of input variable. Input variable is x, so input value is 2. So that's why x is replaced by 2. On simplification, you can see 2 square is 4, 4p. That's not much to do. And f, now right here, now this is the output of the function g2, isn't it? G2, the output of g2 is equal to 11 minus 4p. So this will be the input, this output will be the input for the function f. So input value takes the position of input variable. X of function f will be replaced by 11 minus 4p. Where is x of f? Right here. So this value, this x will be replaced by 11 minus 4p. I can see on your screen. Or 4 my 3 minus 11 minus 4p is equal to 1 by 2. Cross multiplication, we can do cross multiplication. 3 minus 11. First let's open the bracket, let's make it easier. Or 4 on subtraction 4p minus 8 on subtraction 3 and 11, it will be 8 on cross multiplication. Now 4 into 2 is equal to 1, 4 and 4p minus 8 is equal to 4p minus 8 plus 8 16, isn't it? 8 plus 8 is equal to 4p, 16 is equal to 4p. We can clearly see the value of p is 4. 16 by 4, subtracting, this will be 4. Example 8. This is the proof. We can easily prove the left hand side and right hand side. First, let's find the f inverse. Okay, you can see. Now we have to find the inverse. We can see, if you can see the inverse. So just find the inverse first. Just find the inverse first. F inverse. We see f inverse in the equation. So we'll find the inverse first. And if you have forgotten the step, it's on the right top right corner. You can see here the steps. So sorry. Let y is equal to 2x minus 3. Interchanging x and y. Let's quickly move these steps. Left hand side. Our left hand side is f inverse. Takes the function first. Input of f inverse is x. Input of f inverse is x. So output is x plus 3 by 2. So now output of f inverse is the input for f. So this value will replace the x in all x of, and now x of function f will be replaced by x plus 3 by 2. Now this 2 will be replaced by x plus 3 by 2. You can see 2 bracket x plus 3 by 2. 2 and 2 will be cancelled. X plus 3 minus 3, 3 minus 3 is x. So it is identity function. We found that it is identity function. On right hand side also it's very easy, f inverse. Now f is the function which takes the input first. So input of f will be x. Then output you can see 2x minus 3 is the output. X is input, so output is 2x minus 3 and fx is always y, so y is output. Now you can see now x of the function f is replaced by 2x minus 3. We replace this here, right here, right here. This x will be replaced by 2x minus 3. It is replaced already. So 3 and 3 got cancelled. 3 and 3 got cancelled. 2 by 2, 2 by 2 is also cancelled. So that is x. So this is also identity function. Left hand side is equal to. Now this is practice exercise for you. You can do it. 9. We are on example 9. The image of the function, it's given in different ways. It's 5 marks question. First we have to construct the function. You can go. We have to construct the function. First we are going to construct a function f, and you can see here is screen. Now reminder is there. Reminder is from class 9 actually. See the reminder. If x is given, then it's pre-image, domain, input, and antecedent. And if y is equal to fx, then that y is consequence, output, image, and range, isn't it? Now pre-image plus 5. Its pre-image is x. So pre-image is x. We have to suppose pre-image to be x. Then we can construct the function. Image is y. Image is y. Y, or you can say fx is gx, whatever it is. What is the name of the function? Now let's let the pre-image of a function be x and image be y. Now we suppose pre-image to be x and y. You can see in the remainder table also pre-image is x and column and image is on y column. Now priority construction of function. First priority is we are going to construct the function and we are going to find gx. Right now we don't have gx. We are going to construct the function g only. Then we find the gx and we find the composite of g and f and then apply, then find the value of x. Now let's see construction of functions. Now fx will be, let's see what's given on the take note of, let's see, it's the formula, it's like a formula to find now f bracket pre-image equal to image. We have to construct the function as this pre-image must be inside the bracket because it's input. The pre-image is also input, so it must be inside the bracket of the function. So we have to take f bracket x, because our pre-image equal to y is equal to 4x plus 5. See 4x plus 5. 4 times the pre-image means 4 times pre-image is 4x. That will be 4x plus 5. It's given in a simple way. 4 times the pre-image. Pre-image is x, so 4x plus 5. The image of the composition of f and g. G and f, that is g, that is f. Composition of g and f means FOG. Okay, composition of we have FOG. Now our function is FOG. Our input is x. See, our function is FOG. Input is x, and y is equal to 8x. 8 times the pre-image. Pre-image is x plus 3. Pre-image plus 3. Isn't it? 8x plus 13, not 3, 13. Composition of G and F is FOG, F and G is GOF. Okay. Now, to find G, we have done this type of question where we have found the missing function gx already. At that time also we have supposed gx to be a. At this time also we suppose gx to be a. Now we have gx is equal to 8x plus 13. Now g is the function which takes the input first. So input for the function it is defined as constant function. So output is a. Input for whatever input it is, its output is a. It is defined as a constant function. So gx is a. So we replace gx by a because output of gx is a. And now output of the function gx is the input for the function f. Output for the function g is the input for the function f. So a is the input and it takes the position of input variable. That is, same thing is written. F will be replaced by a. C for a. Now this function ax is replaced by a. For a plus 5 is equal to 8x plus 3. We have to make a alone. You can see on calculation for a is equal to 8x plus 8. Now taking 4 common on right hand side, we will cancel this 4 and this 4. a is equal to 2x plus 2. That is gx. Gx is a, and we have found our gx. So we have constructed the function. We have found gx also right here, and now we are going to do composition of f and g. Isn't it? F and g, that will be g of f. Now f is the function which takes the input first. So input is x, so its output is 4x plus 5, isn't it? Y is output. So x of a function g will be replaced by 4x plus 5 because it is the input. Input replaces the input variable. So 2 bracket 4x plus 5 to 8x plus 10 plus 2. On calculation it is 8x plus 12. And now this part, now according to question, it is a bit congested on your screen, I think. According to question, it's given, you can see it's given here, right here, g of f is x is equal to 28. Now we have the value of g of f x, that is 8x plus 12, and we can simplify at minus 12 at x is equal to 14, I think, or it's 16, and x is equal to 2. 8 1 is 8, 8 2 is 16. You can just cancel it. 8 1 is 8, 8 2 is 16. Therefore that's how. Now this similar type of question is given as example for you once again, and then you can see example 10. So this is a function. Okay, let me explain you again. Now see, this is the question, and the image of this is this. This is the image right here, and that's y. And if this is image, then its inverse part is the pre-image. And now output of p is y. Output is this y. So output of p is x. X is output, so p is x. Now this is also the given condition. Now you will first we have to construct. You can see these are the priority, means in this order we are going to solve our question, in this order. Construction of function, it's in the red, means in this slide we are just going to we are going to construct the functions. It's in the red color, means in this slide you are going to see the construction of function only. Here construction of function, and now remainder is there. From this remainder we can easily distinguish input output, isn't it? Input is x, output is y, and image is y, pre-image is x. Now the way to construct the function is f. Take note of how to construct the function f bracket. Here right here it's given f. On other part you can say, in other question if it's given g, then you can write g, where f is generic name of any function, name given to the function. So generic means not specific, not defined. You can instead of f, if it's h in the question you have to use h, if it's g in the question you have to use g. Now you can see f bracket x, pre-image is a plus 3, isn't it? X is pre-image and is equal to output, means y is output. Now second, gp is equal. In this part we are going to construct fx and gx only in this slide. We have already done the construction of function. This will be shown as a recap. Recap what we have done in our previous slide is shown as a recap. F a plus 3 is equal to a square plus 6a plus 11. Gp is equal to p plus 3 by 2. You can see we have this is the recap. We have in previous slide we have done these things, and they are necessary. We did. Now this is f a plus 3. We have to convert it to fx, isn't it? It will be easier to do the solution. So let z equal to let a plus 3 is equal to x, or a is equal to x minus 3. Now from 1 here we have to replace the value of a plus 3. We have to replace a plus 3 by x and a by x minus 3. Now fx is equal to, now fx is equal to a is replaced by x minus 3. You can see a is equal to x minus 3, so a must be replaced by x minus 3. And remember the formula, Okay, many students may have forgotten also. Okay. Now we have to apply this formula and this part only. Now x square minus 2ab plus b square plus 6x, after on multiplication 6x minus 18 plus 11, and this is algebra part. X square minus 6x plus 9 plus 6x minus 18 plus 11, and you can see x square as 6x plus 6x minus 6 cancelled. So this is 20 minus 18, that's 2x square. X square plus 2 is our fx. Now we have to find gx. To find gx, gx is given as xp is equal to p plus 3. It is easy to find px. Now when p is a generic name given to the input variable, isn't it? Input, it's a generic name for the input, so it can be p, it can be x, it can be y also, or we can say if we input x, then it will replace the p from the function. So gx is equal to, it's a dummy variable. Now see, we are going to see g inverse x. Our priority to find g inverse x. On recap, what we did up to now, we have constructed gx as x plus 3 by 2. We only need this part, so this is only, it is written as a recap. Fx is not written. Now step to find that y is equal to x plus 3 by 2, interchanging x and y, or x is equal to y plus 3 by 2, or x is equal to 2x plus 3, interchanging and making y alone. And then that y alone y will be the g inverse x. Why we found g inverse? Why not f inverse? If you have that composite of g inverse and f, to find composition of g inverse and f. So recap, what we did, we have fx square we have fx x square plus 2, and we need g inverse x 2x minus 3, which we found in previous slide. So let's move forward. Now g inverse is the variable which takes the function first. G inverse is not a variable. G inverse is the function which takes the input first. So input is x, its output is 2x minus 3. So let's write f 2x minus 3. You can see now the function x of function f will be replaced by 2x minus 3. Why? Because the output of the first function is the input of the second function. Input for the second function, and input takes the position of input variable. So x square plus 6. Now 2x minus 3 whole square plus 2. Now we have to apply this formula. You have to remember this formula: a minus b whole square, a square minus 2ab plus b. A very important formula. Perfect square trinomial, we can say. Now this is a and this is b. I think it is not necessary to say these things, but still I would like to explain everything. A square minus 2ab, right here a and b, plus b square plus 2 is, if this is the plus 2. And now 4x square minus 12x plus 9 plus 2, 4x square minus 12x plus 11, and this much. Okay, this is our composition of g inverse and f. 4x square minus 12x plus, given on the question. You can see finally we will apply. Now recap. That's the recap. We need only this part, so our recap is on very short. Now we have this is given on the question, so we will apply this. 4x square minus 12x plus 11 is equal to 83, or 4x square minus 12x plus 11 minus 83, right hand side will be 0. Now this is a quadratic equation, and we have to find two number which product is 72, and difference is 12. Now two number difference is 12. Why difference? Why not sum? Because of the minus sign right here. Now let's see the two numbers. The two numbers are, we're taking common ones. Okay. Now it will be easy. Now as 4 is not equal to 0, so x square minus 3x minus 18 equal to 0. As 4 is not equal to 0, 4 is never 0, so second part must be 0. So we have to find two number which our product is 18 and difference is 3. After taking common, it became easier. 6 minus 3. or x square minus 6x plus 3x minus 18. After multiplication, student, be careful here of this plus sign, because minus into minus is plus. On taking common from this 2 and this 2, x bracket x minus 6 and 3 is also common, x minus 6, or x minus 6 and x plus either x minus 6 is equal to 0 or x plus 3 is equal to 0. And our answers are x is equal to now this is for exercise. Now you can see 11, and we have 3 more questions. This question is also very important. We don't have function gx. First we will find function gx. Now there is priority. First we are going to find function gx, then we are going to find the inverse, then we will find the function value of g inverse it. Now gx, to find gx we have now see this entire part inside the big bracket is input. It's input, and it will take the position of input variable. Now this is input, and it will take the position of input variable. Now you can see it's written x of function f will be replaced by gx plus 5. Now 3 bracket gx plus 5, 3 bracket gx plus 5 minus 1. The minus 1 is this, is equal to 3x plus 2. Now you have to understand this part very well. On multiplication, 3gx plus 15 minus 1 is equal to 3x plus 2. We have to make gx alone, or 3gx is equal to 3gx plus 14 is equal to 3x plus 2. 3gx is equal to 3x plus 2 minus 14. 14 goes to right hand side. Or gx is equal to 3 common, and on cancelling 3 and 3, gx is on cancelling 3, this 3 and this 3, we get gx as x minus 4. Now it is very easy to find the inverse. Now to find g inverse x, the step is given. Now first step, let y is equal to fx. In this case it is gx. Into changing x and y, x is equal to y minus 4, and making y alone, x plus 4 equal to y. Now it's alone, so it is g inverse x is equal to x plus 4. Now let's move forward. Now to find g inverse x when x is equal to, now what we have g inverse x when x is equal to 8. 8 will replace x, that is 12. Now that's our answer. Now example 12, two functions fx and gx are given is identity function and the value of x. Now it's some fractions, so we will make it, we will simplify it. Solution, fx is equal to x by 4 upon 5 by 8. Now the LCM of 4 and 8, LCM of 4 and 8 right here, LCM of 4 and 8 is 8. So yes, so after taking LCM it will be 2x plus 5. How? Because 4 we have to divide LCM by the fraction, denominator of the fraction. Then 8 divided by 4 is 2, so 2 must go to the numerator. 8 divided by 4 is equal to 2, so 2 must go to the numerator, isn't it? 2x plus 5 by 8 is our function f. Now another function g of f is equal to 3x minus 3 upon, now in this question also 8 is our LCM, so 2 will go to this side. 6x minus 3 by 8 is our function. Now first we have to find gx, isn't it? Now let's see the priority. We have to find the gx, and we have done it many times, so it will be easy to find the gx. Let gx is equal to 8. We have, or f of gx is equal to 6x minus, or f gx is equal to 6x minus 3 by 8. Now gx, the value, it is defined as a constant function, so gx will be a. Now f a is equal to 6x minus 3, and now x of function f will be replaced by a. Now this x will be replaced by a, or 2a plus 5 by 8 is equal to 6x minus 3 by 8. 8 and 8 will be cancelled. 8 and 8 have to be cancelled. it is cancelled, then it will be 2a plus 5 equal to 6x minus 3. Now we have to make a alone. 2a is equal to 6x minus 3 minus 5. 2a is equal to 6x minus 8. We will take 2 common, or 2a is equal to 2 common. 3x minus 4, 2 and 2 cancelled, 2 and 2 cancel, so a is equal to 3x minus 4. That a is our gx. In this slide we are just going to see the next slide. It's in the red, means now our recap is we have only found fx is and gx are given, isn't it? We need fx and we need gx, so it's both are on the recap. So to find gx, g o f x is equal to g f x. Why? Because f will take the input first, and if x is the input, then its fx is the output, so that is 2x plus 5 by 8. Now g 2x plus 5 by 8. Now output of the function f is the input for the function g, so the x of g will be replaced by 2x plus 5 by 8. Now x of function g will be replaced by 2x plus 5 by 8. So let's move forward. 2x plus 5 by 8 minus 4. Now on taking LCM, 6x plus 5 minus 32. This on taking LCM is 8 and 8 for the 22. Now you can see 6x minus 17 by 8. Now we have found g o f x. Also now we have to, and next slide we have to find the inverse of this priority. Now we are on this step to find g o f inverse x. Now what we have up to now is g o f x is equal to 6x minus 17 by 8. Now we have to find the inverse of this. Let y is equal to, this step is there, let y is equal to 6x minus 17 by 8. Interchanging is the next step, and on interchanging, x is equal to 6y minus 17 by 8. On cross multiplication, 8x is equal to 6y minus 17. On making y alone, at x plus 17 equal to 6y, 8x plus 17 by 6 plus 17 by 6 is equal to our y. Now therefore GOF inverse is 8x. Last, finally we have to apply, it is an identity function, means we have to apply a GOF inverse x is equal to, is an identity. So now we have applying is equal to x, because it's a by definition, is equal on by definition. What we have by definition, on the by definition, fx, if fx is identity function, then its input will be equal to the output. So our input is x, so it is equal to output. Now we have GOF inverse, so that is 8x plus 17 by 6 on cross multiplication, or 8x plus 17 equal to 6x, and 8x is equal minus 6x is equal to 17, that is minus 17, that is 2x is equal to minus 17, x is equal to minus 17 by 2 is our answer, 8.5. Now these are for you to practice, is an identity function, same type of question. Example 13, we have two more questions. Now we have to find gx here, then we have to find f inverse also. Solution here as a given part is, now see, first we have to find f inverse x. We don't have f inverse x. Then we have to find f inverse minus 2, and we have to find g inverse at last. So to find f inverse x, steps are given. Now interchanging, after interchanging, we have to make y alone, x plus 4 equal to 3y. Now we have found f inverse, isn't it? This is the, we are going to find now f inverse 1 by 2. We'll find gx later. And in our recap, we will see our f inverse, which we have done on previous slide, as previous slide is past. it's hidden, so we need the recap x plus 4 by 3. That's our recap. Now we have fx is equal f inverse x is equal to x plus 4 by 3. Our input will be 1 by 2. When x is equal to 1 by 2, f inverse 1 by 2 is equal to x will be replaced by 1 by 2. Now on you can use your calculator on you can do this calculation. It's 9 by 2. Then this 2 and 3 will be multiplied. Okay, this 3 and 9 is cancelled. It's 3. It will be 3 by 2. So second part is also gone. Therefore f inverse 1 by 2 is equal to 3 by 2 is our answer. Now we have to find gx. To find gx, now what we have done up to now, recap, we have found f inverse. We have f inverse gx is equal to 3x plus 2 by 3 and f inverse x is equal to only these two things we need. So that's why it's on in recap you can see these two. So we have g inverse x is equal to this. Now we have to suppose let gx as constant function. We have supposed gx as constant function. We have done 3 times I think already. Now or f inverse gx is equal to 3x plus 2 by 3. Now as it is defined as constant function, now the value of gx will be a, output will be a, f inverse a. Now a will replace all x of function f inverse. Now x of function f inverse will be replaced by a. Now it will be 3a plus 2. Oh, it will be a plus 4. We have to replace here, right here. Okay, sorry. A plus 4 by 3. A plus 4 by 3. Now cross 3 and 3 is cancelled, so we don't have to do cross multiplication as they are cancelled. And we have to find the value of a. A is equal to 3x plus 2 minus 4, which is a is equal to 3x minus 2, that is gx. So easily we found. It's our last question. Example 14, fx is given and f inverse is solved by x. Now it's easy question. We have to find the f inverse, which we will do easily here. Now priorities means we are going to find f inverse. Now to find f inverse, you can see the process. Supposition here you have to be careful, okay, because x is on both numerator and denominator, so little twist will be there, and you have to be agile. You have to be careful. Or xy plus, see y is there on both sides, so we have to make y alone, we have to bring both y together. Okay, now how can we do this? Or x plus 4 equal to 3y minus xy. Now we can take common here, right here we can take common. Or x plus 4 by 3 minus x is equal to y. That's our f inverse. Now we can easily find f inverse 2 also, because now we have to find the composition. For that we have fx and f inverse both. Now f inverse 2, f inverse x is x plus 3 by x. F inverse x is x plus 4 by 3 minus x. Now the output of f inverse is the input for f, so this entire fraction will take the position of x, of fx. Now x of the function this will be replaced by x plus 4 upon x plus 3. Now let's do it. There will be more fractions. Now we have to take LCM also. In the numerator part 3x plus 12 after multiplication, and after taking LCM also when in numerator and denominator in both part, we have to take LCM. Now 3x minus 3 is cancelled, let's see, and 3x plus 12 minus 12 after multiplication plus 4x, minus into minus plus, x plus 4 plus 3x plus 3 minus x. Now on simplification you can see 7x upon 7 upon by x. And now that is the identity function. Let's move. We did Now we have to do f or f inverse 2. Now our input is 2. So as it is identity function, input and output will be 0, the value will be, and solve at fx is equal to 2. Now fx will be equal to 2. It's very easy. Fx is equal to 2. Now we have fx, you can see on the recap, we have our fx as 3x minus 4 by x plus 1, then that will be equal to 2. We have fx is equal to 3x minus 4 by x plus 1, fx is equal to 2. We put the value of fx 3x minus 4 x plus 2 on cross multiplication. 2x plus 1 is equal to 3x minus 4. 2x plus 2 is equal to 3x minus 4, or you can see 2 plus 4 goes to the left hand side, and 2x comes to right hand side. Now 6 is equal to x. Now x is equal to 6. Therefore x is equal to 6. Thank you for watching, and don't forget to check the link on the description below, and